Welcome to this rapid-fire explainer. Today, we're going to break down the absolute essentials of Java development. We're talking everything from the murky depths of JVM runtime failures all the way up to the top layer of application frameworks. So, let's just dive right in.
As you can see, we're taking a real bottom-up journey today. We'll start at the root with JVM crashes and memory issues, move up into observability and performance, and finally wrap things up at the Spring Framework layer.
Part 1. Fixing JVM crashes.
Now, when things go catastrophically wrong at this foundational level, it usually boils down to a few usual suspects. You know the ones: silent memory leaks, those totally unexpected non-zero exit codes, really frustrating class loading exceptions, and of course, the absolutely dreaded out-of-memory error.
But here's the thing. To truly fix these crashes, you absolutely cannot just treat the symptoms. I mean, just restarting the server is not a real fix, right? You have to rigorously isolate the exact triggers. Often that means rolling up your sleeves and analyzing heap dumps during an out-of-memory state, so you can actually patch the root cause.
Part 2. Observability and latency.
Moving up the stack, you really need deep observability if you want any chance at purging latency. Seriously, without specific measurement capabilities actively monitoring your JVM under the hood, you're basically flying blind.
It helps to think of latency as this invisible enemy that's creating a massive performance bottleneck for your application. Observability, then, is your diagnostic flashlight. It's exactly what you use to hunt that enemy down. Simply put, you just can't fix what you can't see.
Part 3. Spring Bean Lifecycle.
Okay, so now at the application layer, this lifecycle maps out sequentially. It kicks off with the core bean initialization, moves right through the auto-wiring process, which is where your dependencies are injected, and then concludes by executing the post-construct phase. You really have to master this flow because it is absolutely vital for overall stability.
So after reviewing this stack from the ground up, I want you to ask yourself, just how prepared is your own code base to debug an out-of-memory error before it cascades into a total system failure? Take these concepts back to your own architecture, poke around a bit, and see where you stand. Thanks so much for joining this explainer, and hey, happy debugging.